Hey folks, if you're absent, thanks for watching my video. This is what we're roughly going to talk about in class today. Okay. We're going to find all zeros of a polynomial function. And you might feel like, hey, isn't that what we were doing in section 5? We were finding all the zeros. Well, we could only find the real zeros. We didn't talk about the other zeros. And there's a theorem, well, the fundamental theorem of algebra that says uh, every polynomial that has a degree that's bigger than 1 is going to have at least one zero. And then they found that they could go further than that and say there's a theorem that says if a degree is n, there's actually n zeros. Like if the degree is 5, then there's 5 zeros. If the degree is 17, there's 17 zeros. And they're not all unique. It's not like you would have 2, 5, 13, -7. You might have 2 as a repeated uh, 0. Like it might have a multiplicity of 5 or something like that. So like, let me give you an example. Like if one of the zeros was equal to, like I said, like let's say 5, then x minus 5 would be the factor, right? But that factor could be to the third power, which means that this 0, 5, has a multiplicity of 3, right? So it's not unique. It's not like, a different number. It is 5 happening 3 times. So that could count as part of our like 17 zeros if our degree was 17, okay? That's a big deal that there's going to be the number of zeros that there is in the degree, right? That the degree is equal to. So that doesn't mean all of them are real though. Okay. So let's talk about like what a real number is and what a complex number is for just a second, right? So we have these real numbers that, we deal with every day, like 5, like 17, like 2.35, like pi. These are all real numbers, right? -17, something like that, right? So what the heck is a complex number? Well, that's when we tack on an imaginary component to it. So it might be 5 plus 2i, or it might be 17 minus 3i, or it might be 2.35 plus pi I, or it might be pi plus 0i, or it might be -17 plus 0i. So look, if there's no imaginary part, 0 is the coefficient in front of the I, then we could really kind of think about it as just a real number. So in a sense, every real number could be written as a complex number. You just put like 0i after it. That's why the real numbers are inside the complex set, right? See that circle in the Venn diagram goes around the real numbers. So when we're doing these problems today, one thing that we have to understand is that complex numbers always have a conjugate pair that they come with. So here in this problem, they're telling us that the zeros are -4 plus I. Oh, and then it gives us just a plain old real number, 1, and another 1. So that's kind of weird. They list 1 twice. Do you see that? So it says coefficients are real numbers that has the zeros 1, 1, and -4 plus I. So see, that's saying that we have a multiplicity of 2 on this guy, right? Multiplicity of 2. And so the x minus 1 factor is going to be squared because there's 2 factors of x minus 1. That's how they have like this 0. It's kind of weird. I don't know why they didn't say multiplicity of 2. And then they give us this one right here, and they're saying that that one would have a partner that would come with it. Always comes with a partner. So -4 minus I is its partner. All you do is change the sign in between the real and imaginary part to make its complex conjugate. So what does that mean? Well, that means that we would have 4 minus -4 plus I, and then we would have x minus, did I say 4 over there? X minus then the -4 plus I, and then we have x minus -4 minus I for our other factor. So these are our factors for our polynomial, okay? Now here's the really bad news. On some problems, all we need to do is just list out the zeros, okay? So, when it says like down here, it says use the given 0 to find the remaining zeros. So all we would need to do is say, okay, well, if one of the zeros is 2i, Another 0 is negative 2i. And then we would do some work with that to find the real zeros. Well, and there should be one, right? Because we've got 2 of the complex ones, and they always are equal to the degree, right? So I got to find another real one. And I'm going to come back to that in just a second. How do you find that real one? But back up here, some of our homework problems, all we need to do is say, okay, 1, 1, and then negative 4 plus I and negative 4 minus I, and we're done. Unfortunately, when they say find the polynomial function, they want us to multiply all this out. Yeah. So we want to have some skills with complex numbers, and we want to have some skills with some real numbers here too. Like, how do you expand x minus 1 squared efficiently and quickly? So x squared minus 2x plus 1 is how you expand that guy quickly and efficiently. And remember how we're multiplying these two together and doubling it to get that middle term? I'm not going to write out x minus 1 times x minus 1 and multiply it out. It takes too much time, okay? Now, over here, I can't follow that little procedure because the number over here is different, right? So I can't just square one of them. They're different. And so I'm going to take it a little slower when I multiply these two together, okay? So let's make sure we distribute the x through. So my first thing I'm going to do is multiply the x through just like that, okay? So I'm going to write that all down right over here. I would get x times x, which is x squared. Oh, I like that one. Then I would get negative x times negative 4 minus I, right? So that's the red part right there, right? Now let's do the blue part. I'd have to take this guy and multiply it over here and over there. Okay, so let's try that. So I go, ooh, man, there's a negative right there, right? So I got to be real careful. I'm going to multiply those two together. So wouldn't it be like a negative? I could think about it that way, couldn't I? Negative x times negative 4 plus I. I think I could do that, right? Like that negative 1 right there times x gives me negative x. And then I got to take, and multiply by negative 4 plus I, right? Okay, let's try that again. A negative times a negative is going to give me a positive. So I'm going to have a plus over here. I'm going to have a plus because a negative 1 times a negative 1 is a positive 1. And then I would have the two complex numbers multiplied together. So I got negative 4 plus I times negative 4 minus I. Now, I'm worried about two things here, okay? I'm worried that we make sure we distribute through correctly and we pay attention to all the positives and negatives and everything. But I'm also worried about how do you multiply two complex numbers together, all right? I don't really feel like this part's going to be too bad, like distribute that x through, distribute the x through, add like terms. I'm worried about these guys over here. So I always like to deal with the easy thing first. Let's deal with distributing the x through. So I get x squared plus 4x plus x times I, or I times x, right? Because it's a negative times a negative. And then I've got plus 4x, and then I've got minus I times x. Now, notice this minus ix right here, or the positive ix and this minus ix, those guys are going to go to 0, right? So we've just distributed that through correctly. We've added some like terms. Now we could add some more like terms together, right? We'll do that here in just a bit. But let's deal with this guy over here. All right, so if we have two complex numbers that are conjugates of each other, that means that one of them is going to have a plus right here and the other one is going to have a negative right here. So that's the only difference between the two complex numbers, right? And so when you multiply together and two binomials where the only difference is the middle sign, you don't have to do the outsides and the insides because they're going to cancel each other out. They're going to go to 0. Okay, so all we need to do is multiply the first together. So that'd be negative 4 times negative 4. That gives me positive 16. And I got to multiply the last together. That would give me negative I squared. Okay, now we need to talk a little bit about what I is. I is defined to be the square root of negative 1. And so if I square I, that would be like squaring the square root of negative 1, right? And a squared and a square root are inverse functions of each other. So that just gives me negative 1. So this guy right here is negative 1. So now I've got 16 minus a negative 1. Man, there's a million negatives in here that we got to pay attention to, isn't there? Opposite of negative 1 is a positive 1, so I've got 17. So I'm going to come right down here and I'm going to put plus 17. Okay, now we still have all this stuff over here. I told you this is unfortunate that they gave us problems like this. And I think I'm going to reduce the assignment a little bit. I'm going to go back in because this is a lot of work, isn't it? And so let's see what we can simplify here first. So I get x squared minus 2x plus 1 all times x squared plus 8x, right? X squared plus 8x plus 17. And now I've got to take and distribute the x squared through. So I'm going to distribute the x squared all the way through. And then I'm going to distribute the negative 2x through. And then I'm going to distribute the 1 all the way through. Look at all the multiplication I have to do. I think I have to do 9 multiplications, don't I? So let's move this over and let's multiply all of that stuff together. So I'd get x to the 4th, because x squared times x squared is x to the 4th. I would get plus 8x cubed, and then I would get plus 17x squared. There's 3 of them. We got 6 more to go. Negative 2x times x squared is negative 2x cubed. Negative 2x times 8x is negative 16x squared. If I miss one of these things, I'm going to be feeling like I don't know what I'm doing, right? 34x, like drop a negative sign or something like that. And then I get x squared, x squared plus 8x plus 17. Shoot, ran off the screen. Plus 17. Okay, so, oh man, where are like terms? Well, we only have one term that has an x to the 4th in it. We have, come on, get a 4 there. 8x cubed, let me put little check marks over the top. 8x cubed minus 2x cubed is 6x cubed. Then I've got 17x squared minus 16x squared, which would be positive x squared, right? One of them. Then I got minus, oh no, there's another x squared over there. So I got 2x squareds, don't I? Because I got an x squared way the heck over here. So let's double check that. 17 minus 16 would be 1, plus 1 more is 2x squared. And then we've got 30 minus 34x and positive 8x. That gives me 26x, negative 26x. And then I've got a positive 17 on the end. Oh, man. That's the challenge, right? So I'll cut the assignment down a little bit because we don't want to do a million of those. Let's see. I hope I made that clear. That's how you find the polynomial if you're given, some of the zeros, not maybe all of the zeros, but you're given some of them, right? What if you're only given one of the zeros? How do you find the other zeros? Because it says find the remaining zeros here. This is almost easier than all of this multiplication. So what I'm going to do is I'm going to set up a little synthetic substitution. I'm going to go 1, negative 4, positive 4, negative 16. I'm going to put one of the zeros right down here, 2i, and I'm going to do my little synthetic substitution. So 2i times 1 is 2i, and then I add together, so I get negative 4 plus 2i. Now I'm going to distribute the 2i through, and I would get negative 8i, and 2i times 2i, let me just do that right out here. 2i times 2i would be 4i squared, which that's negative 1, so I get negative 4, right? So I come up here and I put negative 4 right there. Oh, look at this. Negative 4 plus negative 4, or positive 4 plus negative 4 is 0. So I just get negative 8i. When I multiply 2i times negative 8i, I get negative 16i squared. I squared is negative 1, so I get positive 16. Oh, shocker. I get 0. I got to get 0, don't I? Because they're telling me it's a 0. So if you mess up something in here and you don't get 0, that's an indicator that you messed up some arithmetic. Now let's do negative 2i. And I'm going to use the depressed polynomial right here. So I bring my 1 down, I multiply these two together, and I put it right here. Look at that. Oh, beautiful. The complex part, or the imaginary part, went to 0. So I've got negative 4. I multiply these two together, I get positive 8i, and I get a 0. Beautiful. I'm going to put little boxes around my 0. That confirms I've done the right thing. And then this is my depressed polynomial right down here, right? So what is that telling me right down there? Well, it's telling me that one of my factors is x minus 4. That means my other 0 is 4, right? X equals 4 is a 0. So now I've found all of the zeros of the polynomial, okay? How do I know I have all of them? Well, I've got 3 of them, and the degree is 3. That's how we know we have all of the zeros. Thanks for watching my video. I hope that helps. I hope you can complete the homework assignment. Good luck.